Hi, everybody, and welcome again to Numbers with Nora. This is a math tutoring channel where you can come and watch math tutoring videos on all subjects of math and also put in comments if you need math homework help or step-by-step solutions. For this video, we're going to be focusing on geometry in Chapter 3, and we're going to be doing Section 3.2, using parallel lines and transversals. If you want to follow along in the same book I'm using, I'll put that link also in my YouTube channel, and it's going to be Larson Geometry, and it's a free upload. But if you're using another geometry book, you should be able to follow along as well. So let's start the lesson. So the objective of this lesson is we are going to be using angles formed by parallel lines and transversals and seeing the angles formed by them. So first, let's start with vocabulary. For these vocabulary words, it's better to sit there and see them visually versus words. So I'm going to sit there and draw out what each of these angles look like. So first, we're going to have corresponding angles. In corresponding angles, of course, we have our transversal up here. And our transversal cuts between our two parallel lines, and this annotation indicates parallel. And then our angles that are formed, our corresponding angles that are formed, are going to be angles that are simply on top or on the bottom of our transversal or of our parallel lines, like this. Those are corresponding angles. For our alternative interior angles, again, we have our transversal, and these are both parallel lines. Let's indicate that. And our alternative interior angles are going to be inside of our two parallel lines, but on opposite sides of my transversal. Those are alternate interior angles. Our alternate exterior angles, again, we have a transversal that is cutting our two parallel lines. And remember that exterior means that, excuse me, our angles are going to be outside of our two parallel lines, but then again on opposite sides of my transversal. And our consecutive interior angles, those are just going to be angles that are inside my two parallel lines, but they're consecutive, which means one after another. And our T, and then our lines showing, our annotations showing that our lines are parallel. All right. And you can write these down in your notes and go over these and start to memorize them more and more as we go on, because we are going to see these angles a lot. So next, we're going to go on to our postulates. We only have one postulates in this section. And so that postulate's going to be corresponding angles postulate. So this one states, if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. All right, so let's remember a postulate in mathematics is just a statement that statements that are assumed. So let's draw out what they mean by this. That means if I have two parallel lines, this, I'm going to put my annotation that they're parallel. And let's say it's cut by a transversal. I'll make that transversal black. I'll put T. Then it's saying that the corresponding angles are congruent, and congruent means equal. So my corresponding angle will name this one 1 and this one 2. All right. So that means angle 1, congruent. And we use this symbol, like an equal sign with a little swirl on top, to mean congruent to angle 2. And that's our postulate we'll be using throughout this section. Okay. All right, so let's go ahead and head into example. Let's do example 1, where we're going to identify congruent angles. I'll zoom in so we can see a little bit better. So this one states the measure of 3 of the numbered angles is 120 degrees. Identify the angles. Explain your reasoning. All right. So as we see, this angle right here is 120. We want to sit there and see what other congruent angles or what other angles are equal to 120 and state why. So for this one, if I notice I have this 120 degrees and I have this 120 degrees, angle 5. And we're going to know this because if we sit there and look up our definitions, then we're going to see that those are actually corresponding angles. And by that, corresponding angles postulate, and I'll just put abbreviation, corresponding angles and we'll put postulate. I'll just put POS for postulate. We know that that one's going to equal 120 degrees. All right. Another one that we can see is going to be equal is this angle down here, angle 4. Right, so we can put that angle 4 is equal to 120 degrees. And this is by a theorem that we saw in a later chapter. These are vertical angles, right? Because they share the same vertex and the same side. So they're going to be vertical angles. So this is by the vertical. And again, I'm just going to abbreviate. Vertical angles. And then I think it's congruence. The symbol can mean congruence. And then theorem. All right. Then I can also notice with this angle 4 and this angle 8, that's another pair of corresponding angles, right? Since we already stated that angle 4 is equal to 120 degrees by the vertical angles of congruence theorem, we can also say that angle 8 is equal to 120 degrees. And this is by the corresponding, again, the corresponding angles postulate. I'm just going to use abbreviations. Okay. And these are going to come in handy when we start doing heavier proofs later on in the chapters. All right. So let's continue. Now we're going to sit there and start looking at theorems as well. And the 3 theorems that we're going to be looking at in this chapter are as follows. And remember, theorems in mathematics are just statements that have been proven. So unlike postulates that we assume, theorems have actually been proven, so we know they 100% they're right. So for this first theorem, we have alternate interior angles theorem. So this is stating if 2 parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. All right. So we can say angle 5 and angle 4 are congruent by this theorem. Our next theorem is alternate exterior angle theorem. If 2 parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. So we would say angle 1 and angle 8 are congruent by alternate exterior angles theorem. And this one is a little bit different. This is consecutive interior angles theorem. If 2 parallel lines, excuse me. Right. So this one, if 2 parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary. Remember, supplementary means that they add to 180. Okay, that means when you add those two angles, they're going to equal 180. All right, let me do in this case. In this case, we would have angle 3 plus angle 5 would equal to 180 because they're supplementary by this theorem. Okay. All right, so let's go ahead and use one of these theorems in our example, example 2. This one is using properties of parallel lines. Find the value of x. All right, so there's going to be a couple steps in here, and we're going to use a little bit of algebra, and we're going to name each step that we take. So the first thing we want to notice is that angle 4 and angle x plus 5 are consecutive angles. And from our consecutive angles theorem, we know that angle 4 plus angle x plus 5 is equal to 180. Okay. And we can put that by our consecutive. Again, I'm going to abbreviate because I don't want to waste too much time writing. Instead, we'll just put consect angles theorem. Right. And then our next step is we know that angle 4, let's sit there and note down every single step, is equal to 115 degrees, and this is by the vertical. I'm going to abbreviate angles theorem. Right? Because 115 and angle 4, these are vertical angles, so they're going to be congruent. So now we can use substitution to just put 115 in place of angle 4 plus x plus 5. That's going to be equal to 180. And it's good to sit there and write down every single step because this is what we're going to be doing when we start proving stuff. And this is by substitution. Let's put sub. Now we just use algebra. So let's combine our like terms. 115 plus 5, that's going to be 220 degrees. Or 120 degrees, my apologies. Oops. That's going to be 120 degrees. And then plus x equals 180. And that's from combining like terms. Combined. Like terms. Sorry, it takes me a while to write on here. Term. And then our last step would be to just subtract that 120 from both sides. So I get x equals 60 degrees. And for that step, we can just put subtraction. All right. And that's each and every step that we took to sit there and solve for x. All right. So now let's do example 3. This one we are writing a proof. So like I said, it's good to get used to writing down every single step that you take. So it will help you in writing your proofs later on. So with example 3, we want to prove the alternative interior angle theorem. So prove that if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. So we want to prove that angle 1 and angle 2 are congruent. We're going to use a 2-column proof. But before I start doing proofs, I like to write down some things first before I organize it out. So I can notice that angle 1 and angle 3, those are also congruent by one of the theorems that we saw above. Angle 3. And this is by corresponding angles postulate. Again, I'm going to abbreviate angles postulate. And if you have to relook at that postulate or postulate above, you can. Right. Or actually, I'll just abbreviate. T. Postulate. All right. And then another thing I can observe too is that angle 3 and angle 2 are also congruent. And this is by the vertical angles of congruence theorem. So let's write that note down. Angle 3. Congruent to angle 2. And we can put this by the vertical angles theorem. And then for this one right here, I have angle 1 is congruent to angle 2. And we're going to see this reason a lot as well when we do proofs. Because since angle 1 is congruent to angle 3, and angle 3 is congruent to angle 2, that means that angle 1 and 2 must be congruent because of this transitive property. 3 equals both 2 and 3 equals both 1. So we call that a transitive property. Transitive property. And I'll just abbreviate property. All right. And those are conclusions about that proof. Now down here, we basically did the whole proof, but it'd be better if you sat there and made a table, a 2-statement table, right? And you have your statements and your reasons. And then you write down all those. That would be the best way to do it. Just for time's sake, I'm going to skip that part. If you want to see that part, put it down in the comments and I can make another video of me writing out a 2-column proof. But this one should be good as your solution. Right. Now let's do our last one, example number 4, solve a real world problem. When sunlight enters a drop of rain, different colors of light leave the drop of different angles. This process is what makes a rainbow. For violet light, measure of angle 2 equals 40 degrees right here. What is the measure of angle 1 and how do you know? For this one, I can verbally explain it. So if you notice that both of my yellow lines have the indication that they are parallel, right? So since these lines are parallel, I can look at this pink line as a transversal. It cuts through both of them. When it cuts through both of them, it makes angles. And these angles right here from our theorems and from our definitions above, these ones are going to be alternate interior angles, right? Since they're alternate interior angles, that means that they are congruent by our alternate interior angle theorem. So angle 2 is going to be equal to angle 1, right? And that's for that one. All right, so that's the end for section 3.2. If you have any homework questions or would like further tutoring, please subscribe or leave a message in the comment section. I can show you step-by-step solutions to some of the problems that you're having a problem with, or I can also explain things a little bit more in depth if you ask me to. Just let me know what you need. Thank you, guys.